Hello, I'm Patty Simpson with Simpson Math. We're going to create a box and whisker plot. A box and whisker plot just helps us to see how spread out our data is. Let's look at a 5-number summary. The 5-number summary are just the 5 numbers that we use in a data set that divides that data set into quartiles, or you can think of it as into fourths, so that we have 4 even parts in our data set. And the 5-number summary includes the minimum value of the data set and the maximum value of the data set. Then we're going to find the median of our data set, and so that we're splitting the data in half. 50% will be below the median and 50% will be above the median. Then we're going to take each one of those halves and cut them in half so that we end up with fourths. And this Q1 is going to be the median of that bottom half, and the Q3 is going to be the median of the top half. And that Q just stands for quartile. The upper bound of the first quartile, the upper bound of the second quartile, the upper bound of the third quartile, and then our maximum would be the upper bound of that last quartile. So let's go through and find our 5-number summary for this data set. The first thing we're going to find is the minimum value. And that minimum is just the smallest number. So in this case, 59. Then I'm going to find my maximum value. My maximum value is just the largest number in my data set, in this case 105. Then I'm going to find next my Q2, Q2, which is our median, so the one that is right up in the middle, so that half is below and half is above. So let's count to see how many data values we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Remember that to find the median, we can take that 15 and divide it by 2. So 15 divided by 2 gives me 7.5. And then round it up to the next one so that we're looking at the 8th data value is going to be our median. So 1, 2, 3, 4, 5, 6, 7, 8. This 75, 1, 2, 3, 4, 5, 6, 7 is above, and 1, 2, 3, 4, 5, 6, 7 is below. So we've split our data set in half. That 75 is our Q2. Then, to find our upper bound of our first quartile, we're just going to find the median of the bottom half. So I'm going to look at this bottom half of my data, and I'm going to find the median. So again, there were 7 down here, so divide that by 2, and that's 3.5. Round it up 1, or up to the nearest whole number, so you end up with 4. 1, 2, 3, 4. This 4th guy is going to be our Q1. Notice that there are 3 below him and 3 above him. So we now have 1, 2 pieces. We're going to do the same thing on the other end. Our Q1, though, is that 67. It's the median of the bottom half. Now, our Q3 is just the median of our top half. So ignore this bottom half and just look at this. And again, it should be that 4th one. 1, 2, 3, 4. So this 79 is now our Q3. 79 is our Q3. We've now divided our data into fourths. Here's 1, 2, 3, 4 parts there. So we've divided it into quartiles. That's what that 5-number summary does. Then also when we make a box and whisker plot, we're going to use these 5 numbers to help us make our box and whisker plot. Let's look at the interquartile range. The interquartile range is just the difference or the range from Q3 to Q1, from the upper bound of our third quartile to the upper bound of our first quartile. And that IQR is just a measure of dispersion or how spread out our data is. Inside the IQR, there's 50% of our data. So if you think about on here, we've divided it into fourths with our 5-number summary. In this middle piece from Q1 to Q3 is half of our data. Half of our data sits here in the middle between those two numbers. So 50% of our data is in that interquartile range. So to find the interquartile range, all we do is take Q3 and subtract Q1. We found our 5-number summary here. Let's just take our Q3 and subtract our Q1. So Q3 was 79, Q1 is 67, and so the interquartile range here has a difference of 12 units. The range from one end to the other is 12 units long. And that tells us that the 50% of our data is within 12 units of itself. Remember when we talked about me owning a bar and how I asked all my patrons how much they made a year, and they said $35,000? But then in walked Ryan from YouTube and Ryan's Toy Review, and he made $22 million a year. And he really skewed my data. We would call Ryan an outlier. He's so far out there that he's messing with my data, and he's not a usual data value. He's outside the norm. He's not a normal data value. But what makes an outlier an outlier? How far would someone have to be out there in order to be considered an outlier? Like if Ryan made $50,000 a year, would that make him an outlier? What about $40,000 a year? What is it that makes him an outlier? So we're going to actually define what an outlier is, so that when we look at our data, we can say that one is too far out there. We're going to call it an outlier. And in order to define an outlier, we're going to say that it's anything larger than our Q3. So that upper third quartile, where a fourth of our data is here, we're going to take this Q3 and we're going to add on to it 1.5 IQRs. So we're going to look at our IQR and we're going to add that onto it, and then 1/2 of that and add it on too. And if we go that far out, if it's more than the range of our middle 50% plus another 1/2 of that range, and add it on to this Q3. If it's that far out there, then we're going to say it's too big, it's an outlier. Or it could be on the too small of an end. Maybe one of my patrons didn't make any money at all. Would that make him an outlier? Well, in order for us to find out, what we'll do is take our Q1, that bottom or the top half of our first quartile, upper bound of our first quartile, and subtract from it 1.5 of these IQRs. So anything smaller than that or bigger than on the other end, we will call it officially an outlier. So let's see if we have any outliers in our data set. The first thing that we're going to do is find 1.5 of these. Well, 1/12 is just 12. What's half of 12? That's 6. So 12 plus 6 is 18. So 1.5 times the IQR, you can also do it this way. You can take 1.5 times the 12, which equals, well, half of 12 is 6. 6 times 3, so half of 12 is 6. And 3 times 6 is 18. So I'm going to take, that's 1.5 IQRs. We'd already figured that out. It's 12 plus half of 12 is 6, makes 18. We're going to take that 1.5 IQRs and we're going to add it to this Q3. And anything bigger than that, we're going to consider an outlier. And then we're going to subtract it from this Q1, and anything smaller than that, we're going to consider an outlier. So I'm going to back up a little bit so I have some room. Here's my 18. I'm going to take that 18 and I'm going to, let's first subtract it. We're going to take Q1 minus that 18. So 67 minus 18. Well, down 10 and I'm at 57. Down 8 and I'm at 49. So anything lower than 49 is an outlier. We don't have any smaller than 49. So we don't have any outliers on the smaller end. So then I'm going to take my Q3 and I'm going to add 18. So Q3 is 79. I'm going to add 18, which is 89 plus 8 makes 97. Anything bigger than 97 is an outlier. So in this case, do we have anything bigger than 97? Sure enough, this 105 is an outlier. That is an outlier. So we use this definition to help us to find our outliers. Now we're going to use everything we've just found and create a box and whisker plot or a box plot. A box and whisker plot is just a graphic way for us to display this 5-number summary. And this 5-number summary is going to help us to show the spread of our data, show how spread out the data is. So the way we make a box and whisker plot is first we're going to have a number line, and we need to make sure that that number line includes all of our data values. So I need to make sure that it goes from 59 to 105. So I need to pick some number to count by that is a consistent amount. So to make it from 59 to 105, I think I'm going to count by 2s to make sure I get there. And so I'm just going to start a little below that. I'm going to start at 58. Just a nice round number to count by 2s. So 58, 60, 62. So the same distance each time. And I'm just counting by the same amount each time. 64, 66, 68, 70, 72, 74, 76, 78, 80, 82. What we cannot do is skip to like 100 now. We have to keep counting by 2s the whole way. So once you've picked that value to count by, continue to count by it until you get to the end. So 96, 98, 100, 102, 104, and 106. Next, what we're going to do is we're going to put a dot at our minimum value. So at 59, I'm going to put a dot there at 59. Then I'm going to go out to my maximum value, and I'm going to put a dot at that maximum value. So my maximum value is at 105. Then at 67, at Q1, Q2, and Q3, I'm going to draw a line at each one of those. So at 67, I'm going to draw a line. At 75, I'm going to draw a line. And at 79, I'm going to draw a line. I'm going to connect this interquartile region with a box. Hence the name of box plot. Then I'm going to connect my box to its whiskers. So this line here is its whiskers. Therefore, it's a box and whisker plot. And it shows me how spread out my data is. 25% of my data is in this whisker because we divided this into quartiles. So 25% of my data is here, 25% of my data is there, 25% of my data is in here, and 25% of my data is there. Or Inside the interquartile range, 50% of my data, 25 plus 25 is 50% of my data is inside this little box. So there's a box and whisker plot. But we found an outlier. That 105 is an outlier. And we actually don't include those outliers on our box and whisker plot because it makes it look like this last 25% is really spread out. When in reality, most of it is really close together. It's just that one guy that's way out there. So instead, what we do when we have an outlier is we don't include him as part of our whisker. Instead, I'm only going to stop at 81. I still call 105 my maximum number, but I'm going to stop my whisker now at 81. So that my whisker is right there. Look how much smaller that is. It shows me that that last quartile is actually not very spread out at all. Then that 105, I just put a little asterisk out there that says 105 is an outlier on my data values. If that 105 doesn't fit on my box plot, I can just put a little asterisk somewhere here to let me know that that's an outlier. Then, like all other good graphics, my box and whisker plot needs to have labels and a title. So down here, these numbers were the speed in miles per hour. So I just need to let my reader know that this was the speed in miles per hour. And then I need to have a title on my box and whisker plot. So in this case, it was the speed of motorists or something to that effect. So there we have created a box and whisker plot of our data there of those speeds. And it just shows us how spread out our data is. So in this case, you can see that on this 25%, it's more spread out than it is on that 25%. If we didn't have that 105 there, this would be left skewed because these on the left would skew my data to the left. But that 105 over there really makes it skew to the right instead. So that's what a box and whisker plot does, is it shows us the spread of the data. Let's create a box and whisker plot from start to finish. I have some data here. The following speeds of motorists in miles per hour recorded one Monday. The box and whisker plot is going to show the dispersion or the spread of this data. To create that box and whisker plot, the first thing we need to do is find the 5-number summary. Remember that the 5-number summary is the minimum value, the maximum value, our Q2 is our median, and then the Q quartile, the first quartile, is the upper range of that first quartile, or it's the median of the bottom half. And then Q3 is the upper range of that, or upper bound of that third quartile, and that is the median of the top half. So let's find these values. The minimum value is 46. The maximum is 81. Our median is that number that's straight in the middle of our data set that splits the data in half. So let's count how many numbers we have in our data set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We can take that 14 and divide it by 2. 14 divided by 2 is 7. So I know that because this is an even data set, I'm actually going to have 2 numbers in the middle. It's going to be the 7th and the 8th number. 1, 2, 3, 4, 5, 6, 7, and 8 number. So I'm looking in the middle of that 70 and 71. Right smack dab in the middle of that is going to be my Q2. Well, the number that's in the middle of that is 70 and a half, 70.5. You can find that by adding the 2 numbers together and dividing by 2 if you need to. Remember, that's just the midpoint. So in between those two is 70 and a half. Notice that when I do that, that 70.5 splits it in half, so that there's 7 data values on the left and 7 data values on the right. Then the Q1 is the median of this bottom half. So I'm going to find the middle number of this bottom half. Well, I know I have 7 values, data values on the left. Half of 7 is 3.5. Because it's odd, I'm just going to have one number in the middle. So I'm going to round it up to the 4th one. 1, 2, 3, 4. This one should be my Q1. I can check it. There are 3 here, there are 3 there. So the same number of numbers on each side. So 65 is that Q1, the median of the bottom half. Now I'm going to find the median of the top half the same way. There are 7 data values in here. 7 divided by 2 is 3.5. Because 7 is odd, I'm just looking for one number. 1, 2, 3, the 4th number. Again, notice I have 3 and 3 there. So my Q3 then is 78. I've divided my data set into fourths, into quartiles. Here's the first quartile, the second quartile, the third quartile, and the fourth quartile. And I've created my 5-number summary. We need that to make our box and whisker plot to show how spread out our data is. The next thing we need to do is find the interquartile range. So our interquartile range, remember, is this range from Q3 to Q1. How far is that range? So I'm going to take, to find my interquartile range, I'm going to take my Q3 minus my Q1. So 78 minus 63 is 13. So the interquartile range is 13. Now I'm going to check for any outliers. Is there anybody out there who was going too fast, so fast that we're not going to include him on our box plot? Or is anybody that was going too slow, so slow that we're not going to include them on the box plot? So I need to find those outliers to know if everybody gets included in this box plot or not. To find the outliers, I look for 1.5 IQRs. So I need 1.5 of these. Well, one of those is 13, and then half of that is 6.5. So I'm going to add that together. Or you can just multiply by 3 halves. 1.5 times the 13 will multiply straight across with fractions. You just multiply straight across. So you end up with 39 on top, 13 times 3 on top, and on bottom it's 2. Divide that, 2 goes into 3 one time with 1 left over. 2 goes into 19 9 times with 1 left over. 2 goes into 10 5 times. So 19.5 is 1.5 of these IQRs. Now to find the outliers, we're going to take that 19.5 and we're going to add it to the end of this Q3. So I'm going to take my Q3 and add that 19.5, and anything bigger than that is going to be considered an outlier. So my Q3 is 78 plus 19.5 is, well, we have 0.5, 9 and 8 is 17, carrier 1, 8, 97.5. So anybody that's going faster, greater than 97.5 is an outlier. We don't have anyone traveling faster than 97.5, so we don't have an outlier on that upper end. Let's see if we have an outlier on the lower end. See if this 46 is too slow, if we consider him an outlier. So we take this time our Q1, that bottom quartile, and subtract off the 19.5, 1.5 of those IQRs. So my Q1 is 65, and I'm subtracting almost 20. So it's going to take me down to almost 45, but not quite. So 45.5. So anyone who's traveling less than 45.5 is going to be an outlier. Oh, so that 46 is not an outlier. It's barely not an outlier, but by our definition, that's not too slow. So we don't have any outliers for this particular box plot. Now, I'm going to make my box and whisker plot. I'm going to use all this information to create it. And to create it, we draw a number line. And we have to decide what we're going to count by. I need to count so that my numbers go from 46 all the way to 81. So that's a, not quite 40 distance there. So maybe if I count by maybe fives, or I want to do it as small as I possibly can without making sure that I get it onto the number line. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I can count by twos and get it all on there. So I'm going to use that. I'm going to count by twos. I'm going to start with 46 and count by twos all the way across. Once you've decided on what you're counting by, you must keep that consistent measure all the way through. And you really do want to be able to count as small as possible so that you're not distorting your data. You want to count as small as you possibly can to make sure that you get it all on there. So, if I couldn't have fit all with 2, maybe I would have tried 3. And then 4 to see. Now, I have my number line done. I'm going to just put the 5 number summary on my number line. So at my minimum, I put a dot. And at my maximum, I put a dot. At my Q1, I put a line. So at 65, I put a line. At 70 and a half, I put a line. And then at 78, we draw a line. To show that interquartile area, this 50% of my data, I'm going to draw a box, hence the name box plot or box and whiskers. Then so 50% of my data is in here, 25% there and 25% there. I'm now going to draw this line down to my bottom mileage. So 25% of my data is spread out along this. And then I'm going to draw one more last line from my box to my maximum. And 25% of my data is spread out here in this whisker. So you can really look at the spread and see that the bottom fourth of your data is really spread out, whereas the top fourth of your data is really close together. And it just shows us what that range is in the middle as well. So we really get a good idea of dispersion with the box and whisker plot, or how spread out our data is. Now, with all good displays, we need to have labels. So what are these numbers down here? These are speeds in miles per hour. And then I need a title for my box plot to let my reader know if they want to actually look and see what the information is. So all good displays have those titles. So when we're creating a box and whisker plot, there are several steps we have to go through. First, we have to find that 5 number summary. Then we need to find the interquartile range, this distance here. And we use that distance to find the outliers. We're going to take one of those and another half of that and add it on. And anything bigger than that is an outlier. And then we do the same thing backwards. We take one of those and half of that and we add it onto the end here to see if this is an outlier. That barely wasn't. So then once we found our outliers, we can create our box and whisker plot using our number line. And that's a great show, a great display for dispersion. Math Made Simple at Simpson Math. Thanks for watching.